Hi, today we're going to look at adding vectors, but we're going to look at adding vectors in such a way that we get a certain resultant vector. So we've got a target that we're trying to meet. We've got a question on the whiteboard to show that. So the figure shows an equilateral triangle, ABC, where D is the midpoint of the line AC. So point D is in the middle of A and C. Let the vector A equal AB, so we can draw that in. So that's our vector A. And B is, the vector B is CB. So there. Write the following vectors in terms of A and B. That's our vector B. You may use the diagram to make sketches. So we want to write the vector BA in terms of the vectors A and B here. So BA, that's starting at B and going to A. Now that's just the opposite of vector A, right? That's A pointing in the other direction. We know how to do that. That's just negative A. So we want to flip it the other way, negative A. Now we are after AC. So AC is starting at A and going to C. So it's this vector here. So how can we get from A to C? So this is our resultant vector. We want to build up to it. Well, if we go and we do A and then we add B to it, well, that's not adding B, that's subtracting B, isn't it? Because B is going in this direction. So if we do A minus B, then we're going to end up at AC. So let's erase that out. So we've got our A vector, our B vector. So we've gone up A, we've subtracted B, and we've ended up at AC. Okay. Now we've got AD. And this one's a little bit more tricky. So this time we only want to go to here. Now looking at that strictly in terms of A and B is a little bit tricky to see, but we could also look at finding AD in terms of AC, which we've already found. And we know that AD is just half the length of AC. So we can just write that AD is half AC. Which is half A minus B, and we're done. So the question becomes a little bit more tricky if they just asked originally what AD is without sort of giving you the pre-questions to get there. But the goal of these sort of activities is, if I don't know how to get AD, well, maybe I can find AC. That looks a bit more easy. And then if I can find AC, then I can work my way towards that end question. The last one, we are after DB. So we'll clean this up. So that's our A, that's our B. And we are after DB, and that one here. Now, if we're looking for traveling in this direction, another property of our vectors is it doesn't matter where they start. So we could view this DB as an equivalent vector over here. And that can help us in this case because I can go up A and then I can go across this way. And this vector here is the same length and sort of same direction or opposite direction that's going from D to A, right? So we're looking at this DB vector. We know we have a vector originating from A, so let's shift that DB over here. We can do A, and then we already know how to find this one. So if we're writing out DB, We know that's AB minus this AD vector, because we're pointing in the other direction. So minus AD. We know AB is A, vector A. We know this is AD. Then we can do the algebra. And we get our end result, half A plus B. So when we're doing these sort of addition questions where we're reaching a target vector, so you've got your target vector, it's sort of a little bit of reverse thinking. So if we're adding together vectors, we can get the resultant this way. But if we're given the resultant and two random vectors, well, not random, but we're given two other vectors, we need to look at different ways that we can combine them together to end up with this resultant vector. So that's the video. I'll see you for the next one. This video accompanies a worksheet series that aims to develop conceptual understanding with vectors. If you'd like to access the worksheet, click in the description below.